Okay, question 6. Quantities can either be scalar, so they've just got a size, or vector, they have a magnitude, a size, and a direction. Which of these is a vector? Not mass, but force definitely needs to include a direction, so it is B, force. Figure 7 shows a ball bearing as it falls slowly through a clear, dense liquid. It says, devise an experiment to determine the average speed of the ball bearing as it falls through the liquid. So ultimately, this is just saying, do you know speed equals distance divided by time? Do you know that you need to mark a distance using a ruler? Do you know you need to check the time using a stop clock? And then do you know that speed equals distance divided by time? So to do this, I'm just going to mark a set distance, D, and that's going to use a ruler, mark. Next part, as it falls through there, I'm going to have a stop clock that times it. And the last part is speed equals distance divided by time. So any extra apparatus you would use to take measurements, how would you calculate the speed? So that's all there. We've got what are we doing, what the apparatus we need, what measurements would you take. So I'll just get rid of all of my rubbish writing by the side. So use a ruler to measure a set distance. If you wanted, you could say 10 centimeters, whatever you wanted to pick. Measure the time using a stop clock, or if you wanted to show off light gates and a data logger. Calculate speed equals distance divided by time, and that is it. So we've just got that mix of I need this using this equipment, I need that using this equipment, and speed equals this divided by this. And then last of all is this idea, repeat 3 times and calculate a mean. Done. A student thinks the ball bearing falls through the liquid at a constant speed. Explain how you could develop this experiment to determine if the ball bearing falls at a constant speed. So if I go back to this diagram and delete all of this, really what it's saying is, how could you decide if the speed at this bit is the same as the speed at this bit? All right. And maybe a nice way of looking at this is, well, I'm going to measure a distance here, measure a distance here, and measure a distance here. And then I'm going to time it, time it, time it. These are all the same distances. And if it's falling at a constant speed, that should equal that, should equal that. That's it. So if I draw my little diagram now, I'm going to say, well, I'm going to take this. I've got my liquid, and then I'm going to go split this into 3. I'm going to go distance 1, distance 2, distance 3. And then I'm going to say distance 1 equals distance 2 equals distance 3. They are all the same distance. And then the next part is split that up. And then I'm going to time each using a stop clock. I'm going to use a ruler here. And then how do I know if it's falling at constant speed? Speed 1 would equal speed 2, which equals speed 3. And then I've just done that in terms of words. So set a given distance in the top and the middle and the bottom of the tube. So top, middle and bottom of the tube, set a distance, the same distance. Time, using a stop clock, each fall for the top, the middle and the bottom. Calculate the speed. So speed equals distance divided by time for the top, the middle and the bottom, and see if they match. And there you go, that's 2 marks. And then the next one, the ball bearings now drop through air. The initial velocity is 0, so I'm just going to write a 0 there. The acceleration is 10 meters per second squared, so I'm going to put my A there. And it's going to fall for 1.5 meters, that's the displacement x. And it says calculate the velocity of the ball bearing where it's fallen 1.5 meters. So what do I need to do? Well, the first part is I need that out the way. So I'm going to have to add u squared to both sides. So plus u squared, and now you're gone. Well, the great thing is it tells us that u squared is 0. So ultimately, I can get rid of it anyway. How nice is that? So now I'm left with v squared equals 2ax. But the thing is, it doesn't ask me for the velocity squared. It wants the velocity. So now I know v squared equals the square root of 2ax. And then I can actually plug all that in. So if I was to now show that neatly underneath, we've got v equals the square root of 2ax plus u squared. Now we're just going to put that in. So 2 is the number 2 that you can see there. times by 10 the acceleration, so that's that bit there, times by the displacement, 1.5 meters, plus u squared. And in this case, we said u squared 0, so that bit goes. That gives me the square root of 30 equals 5.47, so the velocity equals 5.5 meters per second. So tricky question to finish on there, and the others are kind of nice, but I would argue that one's a bit of a tricky one to get the wording right, but a nice sequence of questions. Let's go to stop.